In this nugget, we need to go ahead and learn how to troubleshoot issues that relate to the fiber channel domain on a Cisco Nexus or Cisco MDS series switch. So on our Nexus or our MDS, we have the fiber channel domain feature. This is FC domain as we know it at the command line, for example. Understand that this particular feature is responsible for 4 really big important jobs. The first big important job it's responsible for is principal switch selection. This particular element guarantees the selection of a unique principal switch across the fabric. Remember, all of this is on a per vSAN basis. The second job is domain ID distribution. This ensures that each switch in the fabric gets a unique domain ID. Third important job is fiber channel ID allocation. Here we guarantee a unique fiber channel ID assignment to each device that's attached to the corresponding fabric in the switch. And finally, something we'll discuss quite a bit, fabric reconfiguration. This particular element of FC domain is going to guarantee a resynchronization of all switches in the fabric. This ensures that they simultaneously restart a new principal switch selection phase. So the first big feature set is, of course, the principal switch selection. Understand this is going to guarantee that selection of a unique principal switch across our fabric. That principal switch is going to then allocate domain IDs. Let's say this is our principal switch right here. It's going to allocate domain IDs to what are called subordinate switches for that particular vSAN. In order to elect the principal switch, there is a runtime priority that you can configure. Lower is better for that runtime priority. And then there's the lowest local worldwide name that can be utilized in order to automatically elect a principal switch in your fabric. Now, what about the case where we have a fabric merge? So think about it. We are merging fabrics. We would have a principal switch from one fabric and a principal switch in our existing fabric. What's going to happen then? Well, the election of a new principal switch is going to follow some rules. Step 1. A switch with a non-empty domain ID list will have priority over a switch with an empty domain ID list. For a single switch fabric, that particular switch is not going to contain a domain ID list, so the one that does have that list is going to take precedence. What if we have a case where both fabrics have a domain ID list? Well, the priority between the two principal switches is determined by the configured switch priority. You can set that parameter, the lower value the higher. However, when you're connecting a single switch fabric to a multi-switch fabric, the multi-switch fabric always retains its principal switch, regardless of the priority setting on the single switch fabric. Finally, our third principle here with the merged fabric principal switch selection is the fact that if these criteria that we just mentioned can't determine the new principal switch, the lower the worldwide node name of the two switches will go ahead and break that tie, and that lower value of worldwide name will become the principal switch. Now, an obvious question becomes, how do you synchronize things? If you go in and set up a new domain ID value, for example, how do you synchronize the fabric? It turns out there are two methodologies that we need to be aware of. There is a disruptive restart, and then there is a non-disruptive restart. The disruptive restart utilizes reconfigure fabric frames, and they're sent to other switches in the fabric. A non-disruptive restart uses build fabric frames that are sent to the other switches. You see, the issue here is you go in and you make a static name configuration. It is not changing what we call the runtime name that's actually in use. We need to do a restart. We need to do a reconfiguration, a resync of the fabric in order to change the corresponding runtime settings. Now, a great feature for you to take advantage of is something called Cisco Domain Manager Fast Restart. This is when you have a failure in your link leading to the principal switch. If there's a backup link, it can get implemented thanks to the particular restart of the fabric, non-disruptive restart, but it can take up to 15 seconds to complete. So you want to go ahead and really work on that time, and you do so by implementing the fast restart behavior. Just go into global configuration mode as I've done here and issue your FC domain optimize fast-restart for your particular vSAN. Cisco really recommends we do this. But what's our main method of verifying our fiber channel domain settings? Well, very straightforward. It's show fiber channel domain. Here you can see the results for my particular active vSAN that I'm using to send data throughout my data center. It's vSAN 27. You can see that we have stable state for the fiber channel domain, great. A local switch worldwide name, a running fabric name, a running priority, and our particular current domain ID. We can see all this information clearly spelled out. Looking down, you see configuration information like we're enabled, we have fiber channel ID persistence enabled, and something called auto reconfiguration. I'm going to be discussing that in a moment. Notice there's the optimize mode, which is enabled for fast restart. We did that together a moment ago. You can see our priority, our configured domain ID, etc. So this is our key verification command for our fiber channel domain features. Now, an obvious point of troubleshooting would be if you have two switch fabrics and there's two or more switches connected and they have the same domain ID already assigned. What's going to happen here is the E ports that are used to connect the two fabrics are going to be isolated in that particular vSAN. We can use show VC domain list in our vSAN to show our particular domain ID. We can run this on the two switches to confirm that we have an overlap of the domain ID. It's easy to fix. You can go in with the VC domain, give a new number, static, and then your vSAN identifier, in my case 27. And then we do a disruptive restart in order to have this take hold right away. Now, earlier I mentioned the auto reconfigure option. It's off by default, but you could turn this on. What auto reconfigure does is it prevents such isolation like I just described by forcing a disruptive restart of the vSAN. Keep in mind that this would only work if you've got it enabled on all your switches. The new ones you're introducing, the current ones in your fabric, if it's enabled everywhere, then this particular behavior functions. You can't discover you have a domain ID overlap, then turn on the auto reconfigure option and expect it to fix the problem. It's got to be enabled before the problem's introduced. Okay, so we know there is this concept of a disruptive restart. And we know in the case of the disruptive restart, there's going to be these RCF frames that are sent out to the neighboring switches. I need you to be aware of the fact that there is a command in interface configuration mode called fcdomain RCF-reject, and then you would specify a particular vSAN. This indeed will cause MDS 9000 series and Cisco Nexus 5500 platform switches to reject these RCF frames. In order to see if this is configured, you can use the show fcdomain command as I showed you earlier in order to check for this particular setting. So in this nugget, we took a look at the fiber channel domain troubleshooting. We saw this important functionality and the 4 main jobs that it is responsible for in our SAN fabric. And we saw the ins and outs of troubleshooting, both commands that we would utilize and even a particular troubleshooting approach for the worst scenario really I can think of, and that is we have those overlapping domain IDs that we need to hammer out inside our fabric. I sure hope this nugget was informative for you, and I'd like to thank you for viewing.